Okay, I'm back. And as customary, I'm going to check and see if the audio works. Checking now. Excellent. It works. Now to proceed. I will be looking at linear equations, absolute value equations, and linear inequalities. Let's begin. So, I'll just position this. Actually, let me just position this such that that is over there on the left. And sharing my screen, of course. That one. Okay. Now, to begin, we are to sketch the graph of each line. These are linear functions, but here they've turned them linear equations, but no matter. Okay, so looking at this first one, it slopes downwards. That means from top left to bottom right. Its slope is -2. That means a steep slope downwards, more like this than like this. And its y-intercept is -2. So it definitely passes through this point right here. Okay. We only need 2 points to completely and uniquely specify a line that pins the line down on the page. Okay, so we seek another point on this line. To get it, merely substitute any number that you think will work in an easy way. For example, here I'm going to substitute 1. When x is equal to 1, what is y equal to? -2 take 2, which is -4. So it will be down here. Then, using your ruler, just draw a straight line passing through those 2 points as best as you can. And I can see that it will go from there over to there. Okay. Now, did you notice that there was a little bit of hesitation there? Right? Now, they have presented the xy plane from -6 to +6 on both axes. And we want to stretch the line as far as it can possibly go until it touches the borders. So you can labor over trying to figure out what those points are. But for now, we're just going to proceed with the review of the linear equations. The next line is y equals -x take 2. The minus sign in front of the x indicates that it has a negative gradient, so it slopes down. It slopes down. That means from top left down to bottom right. A perfect 45 degrees downwards like that. The -2 means it passes through -2 on the y-axis. It has a y-intercept of -2, just there like that. So we get our ruler tool, and we create it. Just there like that. And that is satisfactory there. Okay. Next. 2x take 5y equals 5. What do? Rearrange it into slope-intercept form. Slope-intercept form. What I mean by that is make it look like this. Y equals mx, plus c. Make it look like that. So how do we do that? Bring this 2x to the other side. So we have negative 5y equals 5 take 2x. Then divide everything by negative 5. So y equals, divide that by negative 5, the 5 right there, and we get negative 1. And divide that right there by negative 5, and we get 2 over 5x. But wait, shouldn't I swap these around? Yes, you can, although that is sort of a superficial move, if you like. Doesn't really add much to it. But anyway, now that it's in this format, we know that the gradient is 2/5. 2/5. And as gradient is defined by rise over run, that means to sort of articulate and say what the slope is, you go up by 2 for each 5 that you go across. You go up by 2 for each 5 that you go across. So I hope you can visualize it here. It will look something a little bit like that. That will be its slope. This is just to help you see how steep it's going to be. Okay, I'm going to leave that there. Now, to actually draw the line itself. Well, it passes through -1. That's the y-intercept. So we're going to put a little dot there where -1 is. But where else should it go through? Well, the beauty of me doing this little triangle here is that you can kind of like use it, you see? You can kind of use it. So just sort of like translate that up there, visualize that moving up. Visualization is an important part of this. And there's your second point right there. You see? 5 along, 2 up. Okay. Get your ruler, draw a line through those 2 points. Okay. Now my ruler and this sort of geometry package that's built into this creates what's known as a ray like that. So really, I have to kind of like go from that endpoint on the left through to the right, and then I have to go from the right through to the left, and it's a little bit tricky for me to see. But it will look roughly like that. And remember to go to the borders of the XY plane that they provide you, and to do so yourself for any XY plane that you draw yourself. Now, x equals -1. What do I do? This isn't y equals mx plus c. So what do I do? This just describes the set of points whose x values or x coordinates are all -1. Okay, so here's a few of those points. -1, 0, -1, 1, -1, 2. These will all be included, and there are an infinite amount of them. Okay, so if you just plot those three, you'll see what it's going to look like. -1, 0, right there. -1, 1, right there. -1, 2, right there. You can see that it's going to be all these points on this vertical line, which is one to the left of the y-axis itself. So let's draw that line. There. That's the line x equals -1. Okay. Next problem. 32 take 2x equals 8y. You've got to get it in slope-intercept form. That's the way to do it. Slope-intercept form. Why is it called slope-intercept form? First, we'll write it out. The general version of it. You know, the template. Here's the slope. The number in front of the x, which by tradition we call m. Here's the intercept. What intercept? Where it crosses the y-axis. aka the y-intercept, right there. And that's why we call this slope-intercept form. But anyway, we've got to get this into slope-intercept form. So how do we do it? Well, you can see that it's nearly there in the first place. Just divide both sides by 8, and you're good to go. I'm going to swap both sides around just because it's easier for me to see it like that. There you go. I just picked up the left-hand side and the right-hand side and just like that. Then I'm going to divide both sides by 8. Okay. Left side divided by 8. Done. 32, divide that by 8. You get 4. Negative 2, divide that by 8. You get negative a quarter. And there it is in slope-intercept form. Okay. The slope is negative a quarter. That means it's sloping downwards. Top left to bottom right. And it's negative a quarter. So that means it's quite a shallow slope. You know, more like this than like this. Right. Okay. But because slope means rise over run, we can make that precise. What that means is, think of a triangle, a right angle triangle that's 1 unit high, 4 units across. There, like that. I should have used my ruler tool, really. I mean, what's it there for? Okay. Much better. The line that we will draw will have a steepness or a slope just like that. Okay, imagine a ball sort of like rolling down there, yeah? Okay. Now, what's the y-intercept? The y-intercept in this case is 4. So, mark on a 4. It has to pass through this point right here. That corresponds and matches C, the y-intercept right there. The slope, as said, is going to be this much. So you can clearly see that another point on the line will be over here. Because sort of like... mentally, you may be imagining that. Okay. Right, now, draw the line passing through those 2 points. And then the other way. Great. Okay, next one. Can you again explain 8y equals 32 take 2x? Sure. So, first thing is, I need it to be in slope-intercept form. I need it to look like this template right here, y equals mx at c. First thing I do is I'm going to swap both sides. Pick up the left-hand side, pick up the right-hand side of the equal sign. Do that. And there you go. Just there like that. To help you out a little bit here, what I'm going to do is I'm going to put the negative 2x in front. Just there like that. All I'm doing is swapping the positive 32 and the negative 2x, just swapping them around, which you're allowed to do. And you can see that it nearly looks just like that, except there's a number in front of y. So what we're going to do is divide both sides by 8. Divide the left-hand side by 8 and divide the right-hand side by 8. So on the left, we have y, and on the right, how do you divide this whole side by 8? One term at a time. First divide that by 8, and we get -1/4 x. Then divide that term by 8, and we get 4. Okay, now it perfectly matches that template up there. This here tells you what the slope is. The slope is -1/4. It will slope downwards, top left to bottom right. How much will it slope downwards? Remember that the gradient is the rise over the run. The change in the y value divided by the change in the x value. That's a fancy way of saying it. But basically what this is saying is think of a triangle that's 1 unit high and 4 units wide and sloping downwards like that. 1 unit high, 4 units wide. And that's going to be how steep the line will be. Okay? Right. So we have an understanding of what that means. What does the 4 over here mean? That means that it will pass through the y-axis at the point 4. At the point 4. That's what y-intercept means. It means where it crosses the y-axis. So we know that it will pass through here, and we know that it will have the steepness of, let's see, I can barely see that. We'll have the steepness of this right here. So sort of copy and paste, or just imagine it being up there, and there you go. That solves it. Now to move on. What about this problem right here? Okay, we need it in the form y equals mx plus c. How to do that? What we're going to do is we're going to try and get y by itself. So we have to take away x from both sides to begin with. Then we have to take away a half from both sides. So we're going to end up with 1/4 of y equals -x, take away a half. Okay, nearly there. But I need this to be y, not 1/4 y. So what I'm going to do is multiply both sides of the equation by 4. By 4. The left turns into y, and the right, well, let's see. -x will turn into -4x. -1/2 will turn into -2. 4 times -1/2 is -2. Perfect. Exactly what I want. Okay. Figure out a point on the line. We know that it will pass through -2 on the y-axis. We know that. But then what other point will it pass through? That's another way that we can do it. We can just establish another point that it will pass through. What you can do is just input any number that you like. Now, if I input the number 10 for x, then my y value will be huge and I won't see it on the page. So what I'm going to input is 1. I'm going to input the number 1 where x is. And as a result, -4 times 1 is -4, and -4 take 2 is -6. So at -1, the y value is -6. So I have a second point. -1, -6. Did I do that right? No, beg your pardon. +1, -6. There you go. Okay. 1 to the right, 6 down. There. Now, draw a straight line passing through those 2 points. And there you go. That's exactly what you want. Yeah, perfect. All right. Okay, so write the standard form of the equation of each line given the slope and the y-intercept. What do they mean by standard form? You may think, oh, I get it. Maybe that's just another way of saying slope-intercept form, right? That would be very nice because then it would be very easy and we could just put this. Standard form, however, is a special word and it means something different. Standard form looks like this. Ax plus by plus c equals 0. Okay? So, oh, whoops, I missed out the x here. My fault. Okay, so it's not going to be this. This is slope-intercept form, not standard form. So let me just move that a little bit over because I'm going to do some work here. There's slope-intercept form. And you are going to transform this until it looks like standard form. So you may think, oh, this is really easy. I just move this over to the left and the 5 over to the left as well. Looks easy. Okay, let's do that. Add 3/5 of x to both sides. And we get 3/5 of x plus y equals 5. Then take away 5 from both sides. And we get 3/5 of x plus y take 5 equals 0. But it's preferable that a, b, and c are whole numbers, are integers, which, as a reminder, are these numbers. Okay? All the natural numbers and 0 and their negatives. How can we achieve that in this case? Multiply everything by 5. Multiply everything by 5. So 3/5 of x. That becomes 3x. Just y becomes 5y. And negative 5 becomes negative 25. Good. That's the answer. Okay, what about this one here? Okay, we have slope-intercept form. That would be y equals 9x plus 4. And we want standard form. So move everything over to the left-hand side. Take away 9x and take away 4. So it will look like minus 9x minus 4. But I'll put that plus y right there. Do I have to do anything at this stage? No. There is an invisible 1 in front of the y. Now you have to write the standard form of the equation of each line. Okay, so here they've basically given it to us in slope-intercept form, and then we are to transform it. So you want to get rid of these fractions. And the way to do that here is to multiply both sides by 5. Okay? The left-hand side times 5 is 5y. The right-hand side is minus 7x plus 5. Then get everything on the left-hand side. So add 7x to the left and take 5 from the left. And there you go. Here, get rid of the fraction. Multiply both sides by 2. 2y equals 3x plus 10. Get everything to the left-hand side and make it equal to 0. Subtract 3x. Leave the 2y alone. Take 10. That's equal to 0. Excellent. Now, expand here. Negative 7 times negative 1. So that's plus 7. Then move everything over to the left. So add 7x to both sides. And for this 4 here, take 7 away from both sides. So just a second here. I'm not sure. Okay. So, where was I? Yeah, take away 7 from both sides. So 4 take away 7 is negative 3. And there you go, standard form. Next, we need to distribute this negative sign. So the right-hand side becomes negative x. Take 3. You just flip the sign of everything inside the brackets. Then move everything over to the left. So it becomes positive x plus y, and then add 3 on the left. There, like that. Okay. Here, it's basically already done. So just add 5 to both sides. Negative 10x, take y, plus 5 equals 0. What about here? Add x to both sides. Put the negative 2y next door to the x. So it's more readable. And that's it. Yeah. Okay. Next up, write the standard form of the equation of the line through the given point with the given slope. Okay. So there's this thing that you do for that. Use this. What on earth is this? Well, if you're given the information that a line passes through a particular point, let's call it x1, y1, and you're given the slope of a line, m, then you can actually use this to work out the equation of the line. So like, imagine that I gave you the point 5,3 and it's definitely on the line. And I also tell you that the slope of the line is 2. Well, according to this over here, you would say, or you would write down rather, y take 3 equals 2, and then open brackets, x take 5. And then you would just sort of sort that out right there to be whatever you want it to be, right? Okay, so we're going to apply that to this case here. We know that it goes through 4, -2, and we know that the slope is -1. So we just use this template up here. We write down y minus -2 equals -1, open brackets, x minus 4. Just like that. Then you clean it up. So minus -2 is +2. So it becomes y plus 2 equals. Now for the -1, just distribute that. So it becomes minus x plus 4. Now at this stage, we have a choice. Slope-intercept form. Slope-intercept form would be like this. Take away 2 from both sides. So y equals -x plus 2. What about standard form though? The form that they actually ask for. Remember, that would have the form ax plus by plus c equals 0, where a, b, and c are all integers if you can make that the case. Okay? So, for this one here, making this into standard form, add x to both sides, and then take away 2 from both sides. So it becomes x add y take 2 equals 0, just there like that. Next, we know that it passes through -2, 4, and we know that the slope is -1/7. So we'll use this here. So just plugging everything in, that's all. Y minus 4, that's your y little 1. So y minus 4 equals -1/7. Open your brackets, put in x, then minus -2. Just there like that. Then you can expand everything out. So y take 4 equals -1/7 x. Now what's -1/7? No, okay, so the double, hold on, it's unstable, the connection. -1/7 times 2 is -2/7. Just there like that. But we want it in standard form. So I'm going to get rid of the fraction. I'm going to times everything by 7. I'm going to get rid of that denominator in the fraction because see to be integers if we can help it. So times everything by 7 now. Y becomes 7y. -4 becomes -28. -1/7 x just becomes -1x or -x. And -2/7 becomes -2. Excellent. We're nearly there. Add x to both sides and add 2 to both sides, and that will make the right-hand side 0, as we want. So x plus 7y, you leave that alone. -28 plus 2 is -26, and that's equal to 0, which is exactly what we want. Okay. Now we have the situation where a line is passing through two given points. So what do we do? Well, you need to figure out the slope, surely. And the slope is the change in y divided by the change in x. The change in y divided by the change in x, which we symbolize as delta y over delta x. What do I mean? I mean -1, -2. That's the change in y. What's the change in x? 0 minus 3. 0 minus 3, which becomes 0 plus 3. So it's just 3. So -3 over 3, which is -1. The slope is -1. Now that we know the slope and we know a point that the line passes through, we can use this up here. Which point do I choose, though? Choose whichever is easiest, whichever you feel you're going to make the fewest mistakes with. Okay, so I'm going to choose 0, -1. Okay, my x1 is 0, my y1 is -1. Okay, so y minus -1 equals -1, that's my m, open brackets, x minus 0. Just there like that. Clean that up. So y plus 1 equals minus x. Move everything over to the left to make it into standard form, and then you get x plus y plus 1 equals 0. Exactly what we want. And here we try the same thing again. First, find the slope. That's the change in y over the change in x. So do -1, -4. That's the change in y. Do -1, -0. That's the change in x. What's this? -5 over -1? Well, that's just +5. That is m, your slope. Now use this. So say y, I'm going to use 0,4. I'm going to use 0,4 because there's no negatives, right? Fewer mistakes. 0,4. So I'm going to say y minus 4 equals 5 open brackets x minus 0. Just there like that. Expand it out. So y minus 4 equals 5x. And move everything over to the left. So minus 5x plus y minus 4 equals 0. Standard form. Done. What next? Write the standard form of the equation of the line described. Well, we know it passes through 2, 0, and we know that it's parallel to this line here. And lines that are parallel to each other have the same slope. They have the same slope. And therefore, this is basically the same as these two problems, 15 and 16. Okay, so we're going to use that thing from earlier that I showed you, y minus y1 equals mx minus x1. Go down here. There, got it back. Remember that x1, y1, that stands for the point that your line passes through. Okay? So in this case, in this particular case up here, x1 is 2, y1 is 0. Okay, so we just pick up those numbers and put them in their spots. So y minus 0 equals, now what's the m value? Oh yeah, that's the gradient. And I've already established that it's 2/3. Open your brackets. X minus, what's x1? It's 2. So you can expand it out. But because I'm going to put it in standard form, I know I want everything to be a whole number as best as I can. So I'm just going to multiply everything by 3. So the left side becomes 3y. And the right side becomes 2, open brackets, x minus 2. Just there like that. Expand on the right. And then your last move is to get everything over on the left-hand side. So I'm going to take away 2x from both sides and then add 4. So minus 2x plus 3y plus 4 equals 0. That's the answer. Similar situation right here. Similar situation. But in this case, instead of 2, 0, it's negative 2, 4. Okay? So I pick up those numbers and I put them in the correct spots. Here where it says x1, I put negative 2. Here where it says y1, I put 4. So y minus 4 equals, what's the gradient? Right here. Negative 3/2. I open my brackets. X minus, what comes next? Minus 2. Like that. We want it in standard form. So I want to get rid of this fraction here. I don't want it to be a fraction. I'm going to multiply everything by 2. Are you ready? Here we go. 2y take 8. That's the left side. The right side, that negative 3/2 just becomes negative 3. I open my bracket and then I put an open bracket. And then inside here, the x minus minus 2, well, that's x plus 2. I'm just cleaning that up. That's all. Expand it out now. 2y take 8 equals negative 3x take 6. And finally, move everything to the left-hand side and make sure that it's all equal to 0. So 3x comes first, then 2y, then add 6 to the left-hand side. So negative 8 becomes negative 2. And there you go. Done. All right. There must be a faster way for me to do this. Can I do that? Yeah, that's great. Awesome. So okay, so we have this information here. We have a line that passes through 2, 4, and it's perp to this. What does that mean? That means it's perpendicular. That means it's at a right angle to it. The two lines meet at a perfect right angle. And what is perpendicular to the line y equals 3x? Can you name a line that's perpendicular to the line y equals 3x? Yes. Here's one. Y equals negative a third of x. How did I get that? Well, if you have a line and the gradient is m, then every single perpendicular line to that line will have the same, will have a gradient of negative 1 over m. All of them will. All of them will. Okay? So 1 over m is just the reciprocal of m. And to do the reciprocal of a fraction, you literally just flip it. 3/5, for example, becomes 5 over 3. In this case, negative 2 over 7, it would become negative 7 over 2. Negative 7 over 2. So it passes through 2, 4. That's my x1, y1. The gradient is negative 7 over 2. And I'm now going to use these two facts, and I'm going to, create the standard form of the equation of the line described as requested. So what's the template? What's the thing that I used, the formula? It's this one again. Y minus y1 equals m, open brackets, x minus x1. So just pick up your numbers. Your x1 is 2 and your y1 is 4. So y minus 4 equals negative 7 over 2, open brackets, x minus 2. Okay. It's easier to turn this into standard form if I get rid of that fraction there. And the way to do that is to multiply both sides by 2. So the left-hand side becomes 2y take 8. And the right-hand side becomes negative 7. And that is left alone. Okay. Expand everything. 2y take 8 equals negative 7x plus 14. And move everything now over to the left. So add 7x to both sides. Leave the 2y alone. Take 14 from both sides. So minus 8 minus 14 is minus 22. And there you have it. There you have it. Problem 22, which I'm pretty sure is the last problem of this set, is that we have a line that passes through 5, 0, and it's perpendicular to the line y equals negative x plus 5. Oh, wait a minute. Uh-oh. I made a mistake. No problem. I'm only human. So, over here, this negative sign should have been a positive. Okay. Easy mistake. But now I'm going to show you how I would correct this mistake. I wouldn't just scribble it all out. I would trace my steps. So that turns into a plus there. That turns into a plus there. And then, hold on now, a little bit too hasty. If I just put lines through there like that, I might not realize. I'm going to multiply that. I multiplied that negative 7 by that negative 2, right? But I was actually supposed to multiply positive 7 by it. So this sign here has to flip. Let me just correct this. Yeah, 7x minus 14. Okay, then moving everything over. All right, so that should now be minus. And then add 14 to -8. Well, that should be positive 6. Error correction. Okay, so we know that it passes through 5, 0. So my x1 and my y1 are 5, 0. We know that it's perpendicular to this line right here, which has a slope of -1. And therefore, its gradient will be the negative of 1 over -1. The negative of 1 over -1. Let me make that clear. Will be the negative of 1 over -1, like that. I'm going to get it right this time. So that is just 1. That is just 1. So what line passes through 5, 0 with a perfect gradient of 1? Using this here, y minus 0 equals 1, open brackets, x minus 5. So y equals x minus 5. And now, finally, getting it into standard form. So take away x from both sides and add 5. So minus x plus y plus 5 equals 0. And that's the final answer there. Okay, all of this was handled. And now we're going to be moving on to something else. Let's see. What's next? Graphing absolute value equations. Something which a lot of people dread. Okay. Let's review the absolute value. The absolute value function. It's real simple. The absolute value of -5 is 5. And the absolute value of just regular 5 is 5. It forces whatever is inside this pair of bars to be its positive self. And indeed, the absolute value of 0 is 0. There's a fancy way of describing it. You know, the absolute value of x equals, and then we do a big brace here like this. And then we say it's equal to x when, like, so we can say, like, if x is greater than or equal to 0, okay, and it's equal to the negative of x if x is less than 0. Okay, a fancy way of describing that the absolute value of a number is that number forced to be positive. Okay, This you would call an absolute linear function. We've just seen linear functions, many of them. Here's an absolute linear function. Like in its general form. Yeah. So like imagine this. If it were just I wonder what caused that. Right, okay. Because it stopped sharing my screen, and I get paranoid about if it's actually recording the audio or not, I'm going to check. Make sure. Just have to check. Okay. Test. Got it. Okay, so it's fine. All right. So this is an absolute linear function. It looks so much like a regular linear function, no? It looks just so much like y equals 3x add 2. But it's not. This linear function slopes from bottom left to top right. It has a slope of 3, so it's quite steep, and it passes through the point 2 on the y-axis. This is a different thing entirely. Think about it. You're feeding in x, values for x, and whatever you get out, you force it to be positive, no matter what. So it'll only have positive values. So will it end up looking kind of like a V shape? Exactly. Let's show you. Y equals. You hold down shift, you press that button in the bottom left of your keyboard, type 3x add 2, and you close the absolute value sign like that. And here we go. We get the V. We get the classic V shape of the absolute linear function. This isn't. I call it an absolute linear function. Okay. Distinguished points. That point right down there is called the vertex. These two parts of the absolute linear function are called the rays of the vertex. R-A-Y-S. This is the right ray and this is the left ray. We would say that it's a V shape opening upwards, if you like. Now, obviously we want to be able to get the vertex. You can sort of see already that it's negative 2/3. So the way to get the vertex is just to solve it ordinarily, and that's how you get the x-intercept, where it crosses the x-axis. So you just solve this linear function, as in you try to find out where it crosses the x-axis, so negative 2/3. Okay. For a general linear function, where does it cross the x-axis? The answer is minus b over a. And the way to see that is just to set it equal to 0. So 0 equals ax at b, therefore x equals minus b over a. Right. Here we go. Y equals absolute of x take 1. Y equals the absolute value of x take 1. It's going to be the V shape. But where will it cross the where will be the vertex of the V? The vertex of the V is the solution of the inner linear, as said. So minus b over a. So in this case, minus 1 over 1. So positive 1. Right there. What will be the slope of the ray? What will be the slopes of the ray? There will be 1 for the right ray. And negative 1 for the left ray. There, like that. Okay, so it's approaching nearly an hour now. Just seeing if that's correct. Yeah, that is. Just deciding whether or not to continue. Experiencing a little bit of fatigue. Yes, I'll continue. Just pause for a second. Take some water. Okay, so the absolute value of x at 4. Now we know that x at 4 ordinarily looks or begins to look like this. Right? That's how it begins to look. And every negative value down there that, I might draw on, all of these are forced to be positive, which reflects the line in the x-axis. So it will end up looking like this. Okay. Y equals the absolute of x take 2. So what does x take 2 ordinarily look like? It ordinarily looks like the perfect line, y equals x, shifted down by 2. Shifted down by 2. So we know that it will start off looking like this. Because it's aiming to get down to there and then continue on forever and ever down there. But it never goes below. Because all these values that I would put in there, which have negative y values, all of those guys are forced to be positive. So it flips in the x-axis, reflected across the x-axis. Now, we know that we've just graphed the absolute value of x take 2. And now what they're asking for is the negative of that. So, logically, that would just flip it in the x-axis again. It would flip this in the x-axis. So that would look like that. There. Just flipping it. Okay, what about this one here? The negative absolute of x take 1. So, what does the ordinary absolute value equation look like? What does the ordinary absolute value function look like? It just looks like a V, like a perfect V like that. I'm going to do my final answer in red. I just want to show you my thinking and the steps towards getting that answer. like that. That's the that's just y equals absolute x. Then I turn it into its negative self. So I flip it in the x-axis. Beg your pardon. Negative absolute x. Okay. Now I have to take away 1 from every single y value, which brings the whole thing down by 1. And I believe that that's the final answer there. So that's just me showing you how to build it up step by step. But let's see if it's correct. I don't want to say something if it's incorrect. Yeah, it's fine. Brilliant. Now, what's the this one here is the negative of the absolute of x take 1. The negative of the absolute of x take 1. So, ordinary x take 1 absolute value. So we can see here plenty how to do that. There's x take 2. So x take 1 will just be sort of like kind of looking like that-ish, something like that. So we'll try that out. Oh, but I wasn't going to use red, only for the final answer. Okay, green. Now, we need the absolute value. We need the negative of that. So we reflect it in the x-axis. Okay. Oh boy. Okay, so I do know like a technique for how you can actually just basically just get all of these things, using the general form. But I don't like doing that because it feels robotic, algorithmic, procedural, as if I don't really understand what I'm doing. So I'm going to try my best to just do it without that. Right, so I'm going to build it up. Oh, like, what's the general name? This is called linear, absolute linear. Okay, when it looks like this. Like, let's say, for example, I'll do an example like A is 2, B is 3, C is 5, and D is 7. linear, absolute linear. And I call this bit the inner linear, the 3 and the 5 stuff. And I call this bit the outer linear. So what I'm going to do is not try to avoid using just the procedures and the formulas that I know. And I'm going to try and work this out. Okay, so ordinary 2x add 2. Ordinary 2x add 2. Just do the inner linear first. Passes through 2 and has a steepness of 2, or a gradient of 2. There. And it'll look something like that. But we want the absolute value of it. So, not using red. Red is for the very end. The absolute value of it will look like this. There. Then we have to multiply everything by negative 2. So if I multiply everything by 2, everything will be like twice as steep. But I've multiplied everything by negative 2. So I'm running out of colors here. I've multiplied everything by negative 2. So it's actually going to be like this. And then finally, I'm going to add 4 to every single value. So it gets bumped up by 4. Just a second here. Beg your pardon. There. Like that. There. Okay. That's me sort of building it up piece by piece. Check if it's right. Hey, it is. Great. Problem 8. Okay. Ordinary, just experiencing a little bit of fatigue here. Ordinary 3x take 3. What does that look like? Well, 3x looks like that. And then you take away 3 from it, and it goes down by 3. So it'll look like that. But we want the absolute value of that. So going from green to pink. There, and there. And then multiply everything by negative 3. So it's going to be very steep indeed. And it will be going downwards. In fact, it'll be so steep, I don't even think that it can fit on here. And then you have to add 1, which has a negligible effect, but it does have some effect. Oh, right, the final answer is in red. I really do hope that was right. I usually just use the algorithm, the formula, the techniques. But let's see. Okay, wonderful. Really good. This is actually quite good. Okay. Ordinary 2x take 3. Let's see if we can do it a little bit faster than that. Right. 2x take 3. That's the start of it, but as you know, it like sort of bounces off there like that. And then double it. So squeeze it. Make it twice as steep. There. All right. I actually quite like this. Okay. Negative 3x take 3. What does that look like? And then take 3. And then do the absolute value of that. And then multiply all of that by 3. So like squeeze it and scale it. Okay. And there like that. That's problem 10, I believe. Okay. Problem 11. Minus 3x plus 4. Okay. Minus 3x plus 4. Minus 3x plus 4. And then the absolute value of that. And then double it. And then like take away 3. So something like that. Okay. All right. Last one here. You know, I may as well flex the formulas for this. So the yeah, as I say, the vertex, and recalling the general form, like that. So it's minus b over c comma d. That's how you get the vertex. So in this particular case, it would be minus minus 2. Beg your pardon, that's not right. Minus c over b comma d. Minus c over d. Minus c over b comma d. So it would be minus 4 over minus 4 over minus 2, which is 2. And then 3. So it's like you get the x-intercept of the inner linear and the y-intercept of the outer linear. That's how you get the vertex. Then what do you want to know? Well, surely you want the y-intercept. And of course, the x-coordinate is 0, and the y-coordinate is d plus a times the absolute value of c. So in this particular case, of course, it would be 0 there. And then 3 plus negative 3 times 4. Negative 3 times 4 is negative 12. Negative 12 plus 3 is negative 9. So the y-intercept is way down there, and the vertex is 2, 3. Like there, and somewhere down there. And, you know, there are formulae as well for the x-intercepts, if you want to call them that, but in this case, it's pretty darn straightforward because everything involved is just a nice and tidy integer. And so the gap, and so the change in y values is 12. but the change in x values is 2, and so it has a slope of 6, and so it's going to be passing through there like that. And then this one will be much the same, like that. Okay. So you can see why I use the formulae or algorithms, but it's still fun to, experience like building up the absolute value functions. The linear absolute linears, interesting process. Okay. Who's next? Or will there be a break? Graphing linear inequalities? Oh boy. Let me just make sure. I mean, if they're horrendous, or is there... No. Do not give up. Continue. Raise your stamina. Okay. Sketch the graph of each linear inequality. Now, the way to approach these is to solve them as if they were a linear function in the first place. That will let you obtain the line. Okay, so y equals negative 2x take 2. By now, we surely know what that looks like. It looks like sloping downwards lines, steeply sloping downwards from top left to bottom right, and passing through negative 2, and with a slope of negative 2. So it will look something like that. Wrong. Try again. Okay, second attempt. You know what? I'm going to go through that point of there. There. And it is, in fact, a solid bar because we have greater than or equal to. But what side of the thing do we shade? Use a test point. Use a test point. The best test point is the origin. Because it's 0, the easiest number to work with in the world. Just plug in 0 where y is and where x is. And just then evaluate the inequality and just see if it's true. So on the right-hand side, we have negative 2, and is 0 greater than or equal to negative 2? It is. And so the origin is included. There you go. Next up, y equals negative a third of x add 1. That's the corresponding linear equation. So solve it. I mean, graph it, rather. There, like that. Stick in the origin, the 0, 0. Is 0 less than or equal to negative a third of 0 add 1? Why, yes, it is, because 0 is less than or equal to 1. So the origin is included, and so shade this side. How about x is greater than or equal to negative 2? Okay, if x is equal to -2, then it's a vertical line, a vertical line that is parallel to the y-axis. Basically it's the y-axis, but translated to the left by 2 units. There, like that. Now, what about my whole is the origin included thing? My is the origin included test? Well, is 0 greater than or equal to -2? No, it's not. Oh, yes, it is. 0 is greater than or equal to -2. This is the effect of fatigue. But we must press on. Here, solving the linear, y equals x take 2. Confirmed. Just there, like that. Stick in 0 in both places. Is 0 less than -2? No. So the origin is excluded. So there. So let's check if these are right so far. Yeah, more or less, except for this one. I don't know how to do a dotted line on here. Is there a way to do it or not? There does not appear to be a way to do it. Okay, that's like a highlighter. You know what? Maybe like gray would be a good signifier, because then that's in line with, like, you know, the colorblind or whatever. But anyway, I need to indicate that, like, I do understand this is dashed. Right. Y is greater than or equal to -2. Y is greater than or equal to x take 2. Okay, if y equals x take 2, then it's this line. And putting in 0 in the y and x spots, is 0 greater than or equal to -2? Yes. Therefore, the origin is included. Therefore, shade in this side. Y is less than 6x, add 1. Convert to grey. There. If y is equal to 6x, add 1, then there's a slope of 6, but it goes up by 1. Right. Like that. And what about the origin? Is 0 less than 1? True. Thus, shade in corresponding side. Fine. This problem here, move everything over. Okay. Negative y is greater than or equal to 5 take 5x. Flip the signs of everything and thus flip the inequality. So y is less than or equal to 5x take 5. Then graph the corresponding line 5x take 5. That was slope of 5. It'll look like that. Consider the origin. 0 in there. Is 0 greater than or equal to greater than or equal to 5? False. So it's excluded. Problem 8. Divide both sides by 3. So negative a third of x plus 1. Input the origin, see if it's right. Is 0 greater than or equal to 3? False. Origin excluded. No. Y is greater than or equal to 5. So when it was the case of x is greater than or equal to negative 2, as I recall from before, that was a vertical line. This will be a horizontal line. So do it. Now, what side is shaded? Here. Problem 10. Move everything over. Divide all by 5. Flip by negative 5. Flip the sign. Two-fifths of x, take 2. What does that look like? Graph it. Input 0. 0 take 0. Is that less than 10? Yes. That side. Divide all by negative 3. So 8/3 of x, take 4. What does that look like? Okay. About there-ish. Is that right? No. No, that's completely wrong. Completely wrong. Beg your pardon. We'll get it. Okay. Just figure out any point. If it's 8/3 of x, it'll have a steepness that is more than 2 2/3. So, and take away 4. So I'm just going to do this line here, which is false. It's a false line. And you take away 4 from it. And you just test the origin. That's true. Okay, one last one now. Goodness me. Yeah, it's y is equal to x. It's that line. Moving the y over to the other side. And then you just have to check the origin. And is that included? Well, yes, it is. Okay, so that's a little bit confusing. So check like 0,3. It is 0,3 is included. 0,3 is not included. So there. Check if that's right. Okay, good. Name one particular solution to number 11. Well, all right. Like, let's say minus 6,6. This guy up here. That's definitely a solution. Can you write a linear inequality whose solutions contain only points with positive x values and positive y values? Why or why not? You cannot, because that would be the first quadrant. Where am I? No. A shape which you cannot cordon off with a single straight line. All right, so that was all handled. It's kind of testing my endurance a little bit, but that sort of is going to end the stream for now. Okay, be well.